Hello everyone. I just want to cover very quickly what do you expect out of the labs. There will be virtual labs for the remainder of the semester. During these times we need to be very creative. So I'm going to use Physics 5A as an example. And I'm going to go down to the labs. All the instructions will be in Canvas. Only the very few labs left over, we're going to cover them using two different types of simulations. And here's one example, Archimedes principle and wind tunnel. The simulation instructions, they will be here embedded in a Word document. All of the simulations that you will have instructions that I'm currently writing. For 5A, I'm done. And then you follow the link. I already have it open right here. And there are three types of software that are required when we run PhET simulations. These particular ones are based on HTML. These ones with a little cup of coffee, those are based on Java. And this one you have to allow Adobe and unblock it and allow it in your computer. The ones that create headaches a little bit for the Macs or Macintosh computers are the one based on Java. So I'm going to open one. Buoyancy is actually the one that was in the help right there. If you go here and look at the software requirements, it kind of tells you what they are. So make sure maybe your computer needs some sort of update or a flash update. Make sure you do that. When you press on start or download, it will start. And then simply follow the instructions and see if you can explain what's going on. There are different instructions for each one, and please do follow those instructions. All right, the next type of simulation is the one based on Java, and those are, I'm going to try to open the one based on Java. Let's pick one. None of them are in my current. Okay, let's pick this one right here, forces and motion. So typically when you download this, you're going to be prompted, at least my computer does that, this type of file can harm your computer. Do you want to keep it? I know that using Macintosh or Apple, it will show a different prompt somewhere else. What you want to say is keep it, and then it's going to load and say open when done. And that will allow you to, you're going to wait, and that will allow you to essentially start your simulation. Follow the instructions that we have. Okay. The last type of simulation, it is based on HTML. So I'm going to open one based on HTML. Again, same thing, read about the software simulations. These actually work pretty seamless on all computers. Based on what I saw, they load fast. You don't have any problems. So here you go. Faraday's law of induction, right? So we're going to put a field line so you see what's going on. You see the current. Anyways, you're going to follow the instructions. Now, another type of, well, this is in an incipient phase, I would say. Lobster is currently in a process of adoption. You will have instructions later whenever this will be implemented. But for now, I just kept a demonstration open.
This simulation uses voiceovers.
And let me...
If you don't have audio, click the speaker symbol on the top right of your laptop to switch to play mode. If you disable the sound effects,
okay,
using your laptop is an
so
important way to
I'm going to say no for now.
Then let's get started with your first
So
mission.
pretty much you're going to follow the instructions. You're going to be...
Welcome to the Conservation of Energy simulation.
All right.
Here you will learn to calculate and manipulate potential, kinetic and mechanical energy to improve the lobster roller coaster. Click continue to start with your mission. Welcome.
Okay, so it's...
Welcome to the Lobster roller coaster ticket booth.
we'll leave it a little
One
bit just to
perk of
see a
working
demo
here
a
is
little bit.
all the free roller coaster rides. Hey, looks like one of our most enthusiastic customers is here again today.
Pretty much follow the prompts.
I am back. I love this lobster ride. I think I have enough money to go on the ride 5 times today.
All right then.
Looks like you're right. You possess the capacity to go on the ride 5 times.
Exchange the money for 5 tickets.
Okay, so this is what I wanted to show you here. Typically in this type of labs, it will highlight kind of like the direction where you have to go, except when you actually have to make your own decisions. That's a little bit different. So here's the money. You put them on the table, and roller coaster tickets, you give it to the
roller
customer.
coaster transforms energy in exactly the same way. It begins way up here above the city with potential energy,
I'm
which
going to skip
You
a
mean
little
it gets
bit.
converted into fun? I heard you guys are going to try and make the roller coaster go over 100 kilometers per
So
hour.
the bottom line of this lab is for you to figure out a way to build a new roller coaster that will go 100 kilometers an hour. And by doing so, you're going to go through the process of conservation of energy.
we certainly are. You just bought tickets from the
Okay,
genius.
so let's
Click on the
continue.
diagram of the roller coaster on the wall to go to the design lab.
Okay. So here's the diagram.
This is the roller coaster design lab. Here, you will apply the principles of physics to improve the labster.
I'm gonna
Click
skip
on
a
the
little
unit
bit.
station to go there.
Here's the unit station.
To your left, you can find shapes representing different units of measurement. Using the formula as a guide, can you correctly place the units on the divider to represent 1 joule, the SI unit for potential energy?
So you have to find your units right here. Right, so here is mass, gravitational acceleration, and height. Mass is measured in kilograms, so you're going to go grab the kilograms from there. And then you have to figure out everything else, right? Meters per second square. And here's meter and how they simplify out, and you put them on. And then you're probably going to start and working on the roller coaster. They give you all the parts. You do all the calculations. You will have a formula board. And here you're going to run all your testing.
Click
So
on the lab pad for more information.
Okay. So I'm going to kind of stop it here with this demo. It's kind of fun. Let me see if I can exit this. So this will be the only type of labs that for now we don't have access other than having discussions in Zoom, but that's pretty good. So keep in mind what you have to do. Please pay attention to all the assignments in the labs category that will come your way. And if you have any trouble figure out the software part on your computer, or if it's not working, please email me. I'm here to support you, okay? Thank you.